Hi, Chris Good here. This is a lecture on two-way analysis of variances, the third lecture that we've had on this topic, and we're just going to do some more examples of how to look at graphs and find evidence of main effects and interactions, and to describe the nature of those main effects and interactions. So I want to take one more try at giving you this example from my own research. So as an undergraduate, I was lucky enough to do research with a guy named Terry Blumenthal, who was studying the acoustic startle response. It's nothing complicated. You just, if you hear a loud noise, you'll blink. We used electrodes to measure the output of the muscle that closes the eye so that we could measure, in how hard people are blinking in response to different sounds. And we could describe these sounds, right, as a graph over time, so time's passing, and then the sound starts, right, and that's the bar coming up, and then when the bar goes back down, that's the end of the sound. And we play really fast sounds, so this is like 50 milliseconds. So the sound comes on, it persists for 50 milliseconds, and then goes off again. That's half of a tenth of a second. And 20 milliseconds, and even 6 milliseconds. And we already knew before we did the study that there's some evidence that it's this, the turning on of the stimulus that's the most important thing, and then the offset, the end of the stimulus, is also important. So when it starts and when it stops, that's really important. We simulated the beginning and the end of stimulus by just a little click here, and it's separated by the same interval. So for the 50 millisecond continuous sound, there's a similar stimulus that has the onset and the offset represented by these two little clicks. So the question we're asking is the middle part of the stimulus really important at all? And what we measured was, out of 100 times we present these different stimuli, what's the likelihood that you're going to blink? How many times do you blink out of 100? So it's percent. It's response probability on a scale of 0 to 1. So here are the results that we published. Turns out we have 4 different durations of stimulus: 6 milliseconds, 20 milliseconds, 50, and 100. And we had 2 different types: the single ones, that's the full bars that I showed you, and the paired ones, the onset and offset. So we're asking the question. The only thing that's different between these two is the middle part. So the middle part's missing over here in the paired stimuli. So you can already see very easily that single stimuli altogether, regardless of duration, this is the main effect of stimulus type, single versus paired. On average, if you average all 4 of these bars together, on average the response probability looks like it's higher for single than paired stimuli. That's the nature of the main effect of stimulus type. And I've gave the F values down here. All of these things are significant. So the main effect of stimulus type was 33.72, that's the F value, and it turns out for the degrees of freedom we were using, that's significant. There was also a significant effect of stimulus duration. Let's see if we can't talk about the nature of that effect. So to do that, you have to average across the other factor, stimulus type. If you're interested in stimulus duration, you have to look at how the dependent variable is changing as that factor is changing from 6 milliseconds to 20 to 50 to 100. But again, you have to average between these 2 stimulus types. So for 6 milliseconds, the average between these 2 is like something around there. For 20 milliseconds, right, this one's higher, but on average it's around here. For 50, the difference between these 2 is even greater, but the average is around here. So as I'm increasing in stimulus duration, right, the longer the stimulus duration, regardless of stimulus type, on average, the main effect is that response probability increases with stimulus duration. So the longer the stimulus, the greater the probability that you will respond to it. But there's clearly an interaction underlying this main effect, right? So you have an interaction when the effects of one factor, right, like stimulus duration, are different at different levels of the other factor, which in this case is stimulus type.